recording, and let's share my screen. And let's hide it. Video panel. All right. Welcome everyone to another episode of writing Bitcoin smart contracts, is specifically using the SDScript TS libraries. So today we are going to cover so-called standard libraries, right? So previously we went through many examples, and you can pretty much write all of them from scratch, but that's not usually the way how you do it, right? So for a lot of common functionalities, for example, today we are going to talk about, for example, Elliptic Curve, or how do you verify oracles, all these common functionalities. We don't want every user to write their own from scratch, right? So we provide for the most commonly used functionality. We put all the libraries out there, so you can just go there and import it and use it. You don't have to know it to understand it, but it's also all open source in case you are curious. So how do we navigate there? I mean, again, you can go to our main webpage, and then you go to publish, which I think we covered in one of the episodes before. So in the last section, we have this SDScript TS lib. So if you click here, you'll go to the repo here. It's open source, and everybody can please like it, fork it, whatever you want. So here is still work in progress. So as I said before, the main purpose for this library is to provide all the most commonly used functionality. So, not everybody has to write from scratch, right? So today I'm going to cover just a few examples, and I'm also going to tell you what kind of new libraries are coming. So that will be very useful. So first of all, these are the tests, and we just most focus on the where the source code is. So here we have a big few categories. I think at the outmost we see this wrapping signature. So just curious, how many people have heard about this before? Wrapping signature? Anybody?
Yeah. I've heard of it.
What does it do?
Isn't it a sort of multi part signature or something?
Yeah, close, I would say. So the short answer is, we have this, I'm going to put this all the links in the show notes, but one way, on a lot of smart contract platform, right? It's almost like given. Oh, you need to have this kind of oracle to import, off-chain data into the smart contract, right? Because smart contract doesn't know the external world, whether it's raining, who has won the lottery, or what's the price of BTC or BSV today, right? It doesn't know. So usually this is imported through some kind of like a trusted third party called oracles. So the way you can verify smart contract is you check, this any arbitrary piece of data is actually signed by the oracles. But here's the problem for Bitcoin, because native the signature, so-called ECDSA, you can do it in Bitcoin, but it's quite expensive. I think I'm going to cover later. But so that's an alternative. So think about Bitcoin. When you send from address A to B, usually to check the signature, it's using one signature scheme called based on Ellip Curve, ECDSA. So you can implement that in SDScript, but the problem is quite expensive. So wrapping signature is an alternative signature scheme, which is very lightweighted. I think you can even have less than 100 bytes or something, tens of bytes. It's very efficient. So the good thing is, you don't have understand all of this. So we already, wrap it around in this wrapping signature. So you can just import it, and then you can easily verify the signature using this library. So once you have this, basically what it enables is you can import any arbitrary off-chain data into a smart contract, as long as you can find any trusted oracle. Make sense? And once you have Oracle, right, you can build, it's an entire new world of smart contract, so-called dApps. You can build upon it, right? You can say, oh, I have a contract. It's a binary, option contract at a certain date. If the price of certain commodity or, even cryptocurrencies is, above this price, somebody wins. If not, somebody else has to pay the difference. Or you can even say, oh, you can bet on some so-called prediction market, right? You can say, oh, what's the weather like, or who's winning this, this football game or whatnot. You can have all kinds of applications based on this or this single library. I leave it to you. What kind of other libraries you guys can build out of this, but it's the possibilities is just unbounded. The short answer is any oracles you can build using this scheme, and also we have all the you know all the libraries also implemented, so you can create a signature. You can also verify it. Everything is wrapped. Okay. Anything about Robin or the Oracle? Okay, sounds good. So I just briefly talk about the Ellip curve. So how many people up here have kind of understand like what the Ellip curve is, or how does it play in the space of Bitcoin?
I just
I have,
know that it's used to like in some calculations, but I don't know the details because my math not strong enough.
okay. Anybody else want to tell me what's the experience with Ellip curve so far?
What do you mean the experience with it? I mean, it's mostly hidden behind some library, isn't it? They don't
Yes.
normally use it directly.
Mm-hmm.
But yeah, I'm sure
Yeah.
we all know of it.
Cool. So in summary, is Ellip curve math is kind of like a field of cryptography, and it's a primitive. It's almost like the Robin signature for articles. It's a very basic, you know, arithmetic. Once you have this elliptic curve, usually we could do two things, right? Addition. So basically, why it's called elliptic curve, right? So basically, you have this kind of function defined by some kind of you can see here the formula here. So for example, you know, this is the curve. You can draw it on the x, y coordinates. But once you have the curve, you can define so-called addition. You know, for 2 points, if you want to add these 2 points, what's the sum of these 2 points? It's not every point has x and y coordinate. It's not a normal regular addition, right? So the kind of addition is, you can think about it, it's almost almost like a function overloading, in a programming language paradigm. But basically, you can
Yeah.
define you use the size addition, but it's not just add the x and y coordinates. It's a different term. Basically, there's a way to add them, and then once you define the addition, you can of course define multiplication, right? So if x times the point p is basically you add the p to yourself, right? K times, right? So why this is very interesting, because a lot of cryptography, we are in the blockchain Bitcoin space, right? A lot of time you are dealing with cryptography, and this cryptography either is encryption, decryption, or signature scheme, or even later on we talk about maybe one of the most advanced cryptography, zero knowledge proof. Is a lot of time you are based the operations is based in the elliptic curve space. So the basic primitive, how do you add two points, and the other one is so-called scalar multiplication. Is how do you, pretty much you time. How do you time a scalar to a point? So once you have these basic primitives, it's like that. It's like Oracle again. Robin said you can have tens, if not hundreds, even thousands of, cryptography you can implement in a script. So the difference is that you don't need to add new opcode or breaking changes. You can just implement all this based on this primitive, right? So for example, I think one of the most famous example is the so-called, again, right, ECDSA I just showed. When you do the signature checking, actually you are running this, so-called signature verification scheme. It's also based on, because it is EC, so this is Ellip Curve, digital signing algorithm. So basically you are running this algorithm. And this algorithm is like any other algorithm, can be implemented in your code, right? And once we have the addition and scalar multiplication, you can, then it's a basic building blocks. Then you can implement ECDSA actually inside your smart contract, right? By default, that probably mentioned a little bit earlier. So why we don't use this for the, for importing Oracle data? In theory, you can do it, but the rapid signature is just much more efficient. I think here we are talking about probably on the order of 100 kilobyte script. So there is only like 100 megabyte. So it's about 1,000 times difference. So that's the reason. I mean, you can do it. And then another question is, we already have the ECDSA building in the Bitcoin, right? So why do we want to, implement another version here? Anybody has a guess here? We already have the checksig opcode, right? So why do we want to almost like re-implement it in our user code? Liam, you want to have a guess?
Why do you want it in SDScript? You're asking?
Yeah, why do you want to reinvent in your smart contract? Why not just use, we have the checksig, right? So we have the built-in function checksig. Why do you re-implement from scratch? Okay, so
because
let's go ahead.
Checksig just checks the sig on the what do you call it? On the pre-image, doesn't it?
Yes.
And this can be used to check any signature, I suppose.
Yes, 100%. So in the Bitcoin checksig, as Liam just mentioned, you cannot check the signature on any messages. The message has to be like, you can almost think about only for the current transaction, more precisely the, sig hash per image, but let's scale over that. So basically, when you have a signature in a transaction, this signature is only against the transaction data. Okay, so digital signing, right, for people just want a brief reminder. So the idea is you have a piece of data, a so-called message, you can use a private key to sign it, and then later on, somebody who doesn't have that private key, you only have the signature and your public key and the message, they can check whether it's signed by you. So here is, the message is very limited. It can only be one format. It's the transaction pretty much. But then that's not very useful, right? For example, you want to import some, let's say, weather data, right? But then you cannot sign the weather by using the default one. So that's why it's very useful here, because this message here can be anything, okay? And thanks to the Ellip Curve library we have. I mean, here, if you implement from scratch, it's going to probably take quite a lot of time. But since we already have the library wrapped up, here, so this is a so-called, even for Bitcoin curve, Ellip Curve, they have many families, but for Bitcoin curve, this is so-called, SECP 250K1. So basically, it's one type. For the basic idea is there are many Ellip curve. There are many different, each one has their own properties, right? Security level, whether it's so-called zero-knowledge friendly or whatnot, so many different variants. So for Bitcoin, uses this curve, and we implement the point addition and scalar multiplication and a bunch of other things. So could you imagine, why this is pretty sophisticated, right? Because a lot of time you want to have the most efficient implementation. So not only we implement this, but we also optimize this So you don't have to write from scratch. I mean, you can just import this library and then use it in your own smart contract. So just give you another sense, why I think Ellip Curve is the basic operation is very important. So another thing is you probably heard about this. We just talked about you can implement ECDSA, right? Signature. And you can implement many other cryptography. One of the example is so-called Schnorr signature. So how many people heard about this one signature before? I think we talked about a lot of signature scheme today. Just heard about it, doesn't have to know anything about it. Just okay. Usually it's associated with which blockchain you heard it from? Yes, mostly. Go ahead.
No, I was just going to say I heard it at Nchain a lot.
Oh, okay, great. So yeah, if you're not heard from Nchain, most likely, like if you're like me, I heard it always from BTC people, because this has been hailed as like almost like the biggest breakthrough after SegWit or after release of Bitcoin or something. It's going to be, they claim it's huge. Yeah, I'm not going to argue with that whether it's going to be huge or not, but they implement this and ship it together in the Taproot upgrade. So now they have Schnorr signature. It's another digital signature. Also, you can implement on Ellip Curve. What I'm arguing here is, hey, I'm not saying it's not good, or it's not as good as what the BTC people claim, but even if it's good, actually you can implement this again using the Ellip Curve library in Bitcoin directly. You don't have to change everything. So they spend like a very many years and many developers actually to implement this. So again, here's story is, once you have the Ellip Curve library, you can also re-implement this in your contract. If you really want it, you can use it, just a few lines of code. So you don't have to derive, always have breaking changes. So the one of the biggest differences, Schnorr signature allows so-called aggregation, right? So for example, in a Bitcoin transaction, what if you have instead of one input, you have three inputs, right? So if you use the default signature, ECDSA, so each one has the signature, right? So when you check, you have to check 3 times, right? For each input. Make sense? And one of the benefits, of so-called Schnorr signature is you can aggregate them. So instead of have 3 signatures, you can aggregate them into almost like a group signature, like share signature. So you can check this signature once, and if this verification is correct, you are sure all the 3 is good. So that's one of the potential benefit. Okay, so if this is not enough, I'll show you another example, which is pretty cool. So basically, we have another cryptography, but you don't have to know all the details. It's called algebra encryption. So basically what it does is, if I encrypt something, right, and then I want to have a contract saying, hey, if I give you this, the ciphertext, the secret, right, after the encryption, and if you give me the plain text, I will pay you, right? So what if a lot of times, right, I want to have this so-called fair exchange of secrets. For example, you go to, let's say a Netflix, but on Bitcoin, right? I have this movie, and if I'm Netflix and you are my customer, if you pay me, I will give the decryption key for this movie, right? Vice versa, right? So if I give you the decryption key, I want to make sure you are going to pay me, right? So usually they have this kind of it's a dilemma, almost impossible to solve. If I give you the encryption key first, you may run away and not pay me, right? Or vice versa, right? If you pay me first, I may not give you the decryption key. So here, this is I think it's a cool example of the usage of smart contract. So basically, I put a contract. What this contract says is, you can only get paid if you give me the valid decryption key. Okay, is this clear? This is how what this smart contract does and why it's useful. I call it pay to decrypt. Okay, so you want to implement some kind of encryption. So this one I call I use Algama because it's very easy and it's based on Ellip Curve. So again, you can. I'm going to put this in all the show notes. But the short answer is, short story is, it's also based on Ellip Curve. So you can easily re-implement this. Just a couple lines of code if you already have the library. So this is a very cool example. If you want to make sure the secret and the payment, they go atomic. They never go one direction only. Either both happen or neither happen. Make sense here?
I think so. Yeah.
Okay, nice. So this is just give you a couple examples. I mean, if you read our blog, you can maybe find at least 10 other examples. It's all real, and this is just basic primitive enables you to build all kinds of new things. Just a couple lines. Okay. I think that lastly, I want to, emphasize the benefit. So if we go back to ECDSA signature, right? So if you notice here, all code is written by users. So one of the concerns, right? You always heard about people claim, oh, what if one day quantum computer or more advanced computers come in, and they can break the curve I just showed you, the Bitcoin curve. Even from the name you can see, right? The key space is 256 bits, right? Which is super big. But what if people just sometimes they are worried, or you can sometimes call it a super paranoid. What if some computer can break it one day, right? But no problem, right? But then instead of asking everybody to change the Bitcoin code node, what you can do instead? You can implement another curve, right? For example, maybe 512 bits, and then you just lock up your funds in this new contract, right? You don't have to upgrade to ask everybody to change the node software or the entire ecosystem, right? Because this is just another contract. The Bitcoin doesn't care, right? The only difference is it's not built-in, right? But you pay a little bit more price, but you got more safety if you really want to do it. So the good thing is you don't need to switch out the default, the built-in signature scheme, or you can just code a contract and then lock your fund to it. That makes upgrade. You don't need to upgrade. So that's what I'm saying. That's a huge benefit. Make sense? So here, there's nothing saying you cannot use another curve, or another digital signature scheme. You can lock up your funds because people are worried. People may break up the better computers may break up the 256 ECDSA very soon, or in the next 10 years or something. Okay. All right, let's go to another one. So we just talked about, the oracles and the elliptic curves. I think the next thing, I think I'm going to at least spend one episode or two, or maybe a few, in the future to cover more. Basically, it's the zero knowledge, primitives. So this is a much bigger topic. I think we're going to save for a future episode because it's quite deep. It can build all kinds of new applications, smart contract on top of this. So the basic idea is we also implemented the zero knowledge primitive. So if you want to have your contract use a so-called zero knowledge proof, you can import this library and everything is ready to go. You can then import it and just fill the lines of code. You can verify the proof in your contract. You don't have to, because if you look at the code, it's quite contrived. You have to go through a lot of things. So we already have this, so you don't have to go through all this complexity. It's using another Ellip curve here. It's basically called BN256. So it's a different curve from the Bitcoin native curve. So that's why you have to reinvent. This is quite contrived. So the good good news is we already done the hard work, so you don't have to know all the details. You can just import it, use it. Okay, I think I'm going to stop here for today, and I think I'll save some other days future for the zero knowledge proof because I think it's very interesting. So, any questions about the topics covered today?
No, I just wanted to say that I need to go, so I'm glad that I
Okay.
been to the end.
Okay, very nice. Yeah.
Bye.
Yeah, sure. So it's good thing is I think it's as I said today is a little bit special because I think at least Jens has a few questions, so it's good to have almost like an office hour.
Mm.
So if anybody who have any questions about SDScript so far, I think you can ask them now.
So,
Feel free.
how many? I was going to ask, how are these being used in the wild? Are there lots of projects using these at the moment, or is it still the SDScript TypeScript library? I mean, is it still too new for that?
You mean okay? So break it down to two parts. One is are there a lot of people using the old like vanilla SDScript
No, this
or this
TypeScript.
this
Yeah,
this one? Oh, because it's so new. I think it's
yeah.
I'm not aware of people who are using it in the wild, but I've seen a lot of people tinkering with it, learn it every
Mm.
single day. So I think people are picking it up.
Okay.
But for all this primitive, because we also have the equivalent in the old like a vanilla script.
Yeah.
So they're being used extensively, right? Ellip
Yeah.
Curve, especially the Oracle ones. I think people are using it for oracles to sign all kinds of data. Yeah, it's picking up. I hope you guys will be the pioneers based on this to see what kind of new things you guys can think of.
Yeah. How did the hackathon go?
Yeah, very good. I think that's why we
I
have
didn't hear.
for people who have not heard about it. So we have this first zero knowledge hackathon held about in last month. So we have hundreds of participants, and then eventually we have 10 finalists, and then out of 10 finalists, we have the 3 winners. But all of them is very cool usage of the zero knowledge combined with Bitcoin. Check out the different winners. For example, we have this guy built a zero knowledge version of Minesweeper. So I assume everybody has played the Minesweeper, if
Yeah.
not 10 years ago or maybe yesterday. So basically, you can hide all the mines where they are, right? You can put it on chain, but nobody can see them. But also, you can make sure the server is not cheating on you, right? Because if you hit that's a mine, it's a mine. You cannot just say, hey, the region is empty, but if I click, I just have a false positive. I always kill the player. That's just not fair, right? So I think I'm going to also put in the show notes. Yeah, yes, and people have built a text hold'em poker kind of game, and people do like zero knowledge proof of reserve for crypto exchanges. Yeah, so yeah, that's why it's pretty interesting, fascinating.
Cool.
And this is only the first one, so I'm going to at least do this every year, if not every quarter. So from now on, so definitely, if you want to show off your SDScript or smart contract skills, definitely something to to watch out. And
Yeah.
also, not only you can get the the badge, but also win real dollars, right? So here, first we have $45,000 in prize in total. So if you're first, you got you got 20 grand, which is pretty decent if you want
Not
to
bad,
spend
yeah.
like some weekend, to show off your skills.
But there
So
wasn't a first, there were just 3 winners, or was there a first, second, third?
oh, there's the first, there's second, there's the third.
Okay.
Yeah. I think in this website doesn't show up, but I think this is the order based on the order. Yeah. So basically, we
Okay.
have a huge panel. We have quite a few. I think it's all-star judges, if you ask me. So we have of course, Craig Wright, and also Jens. You probably heard about this guy. if you are in any kind of zero knowledge space. So this is the guy who
Oh,
invented
that's
so-called,
funny.
yeah, Gross 16. So this is the Gross. So he, basically this guy is in zero knowledge is like a crack in Bitcoin space. He pretty much invented the most popular zero knowledge algorithm used by everybody. Zcash, Ethereum 2.0, whatever you name it. So it's very, yeah. I'm I'm looking forward to the next, yeah, just yeah. And you got paid in real Bitcoin, so
Cool. Thanks.
no problem. Okay. Yes, you seem to have some questions.
Yeah, for sure. I mean, if there are no other questions on what we're covering today, these are, I mean, they're pretty noobish questions, so I apologize for that. But
Yeah,
running
there's
into
no silly question here. So that's what we're here for.
yeah, so what I'm running into is so I'm building a bounty system basically, which relies on a four-step life cycle, being bounty creation, submissions to the bounty, then a selection of the submissions, and then once a submission is selected as winner, you can claim the bounty, which should unlock the tokens. What I'm running into is I've written everything written out and it works locally. But when I test it on testnet and I chain all of these transactions, the claim transaction fails. That said, if I just test the claim transaction on its own on testnet, it passes. So I don't know if I could maybe share screen or something to show
Yeah,
it's like
if you want to share screen, yeah, sure. Go ahead. Let me enable you to do it. Okay, you can now go ahead.
Thank you. I'm not sure what I'm not seeing. But is this visible?
Yeah, I can see it. Okay.
Yeah. So basically, when I test the entire life cycle, all of the transactions, so here they pass individually. So here claim passes individually, select passes individually, submit passes individually. When I chain them, which basically when we submit, select, claim, submit passes, select passes, but claim fails with the
Oh,
output
yeah.
error,
Okay.
but
So,
not when I do it alone.
okay. Yeah, I kind of see what's the problem. At least from the error message, looks like the you don't have any outputs for these transactions. If based on the
Yeah.
error code.
Mhm. There indeed are no outputs, but what surprises me is that it doesn't fail when tested alone. Shouldn't it also fail? Because it relies on the same, these two tests rely on the same code. So this one,
Okay.
but it
So
just
if
failed.
okay, so I have one hypothesis. You
Mm,
can check later. So here's it,
mm,
right? So so the Bitcoin smart contract when it runs, right? As I said before, the benefit first is so-called Ethereum or other companies is so-called pure, right? It's almost like a pure function. So you check whether it's pass or not, right? It only give you a yes true. But the problem I guess here, I assume you already chain your transaction locally. Have you?
Yes, and
When
it
you do the
works.
local. Okay. But then when you check it locally, it
No.
doesn't it doesn't check the trend whether the transaction is well formed. Do you see what I
Mm,
mean? So if you're missing output because to the contract, if it's as a transaction, it's a context coming in, I run all the calculation, it give me true, that's give me true. But so when you send it to the testnet, because testnet is kind of real, right? Not only
yeah.
the smart contract has to be true, but also so here's the thing, for a transaction to be valid, you have you have several requirements. One is the smart contract has to be evaluated true, but that's a necessary condition, but not sufficient, right? So if
Mm,
you set locally, because pretty much it's only check the contract is good, but doesn't run other transaction validation. For example, whether the contract is well formed, right? Whether you have inputs, outputs, whether the sum of the inputs is you know, it equal or more than the sum of outputs, right? The smart contract side only cares about, you know, whether this can unlock is the key matches the lock. It doesn't check other transaction level stuff. Do you see what I mean? It doesn't check whether UTXO has been spent. It doesn't check whether you have outputs. So my guess is you are missing some outputs in when you whatever claim.
And claim, yeah, absolutely, yeah.
Yeah.
So
You have to fill in when you create a transaction. Yeah, you only have inputs. Looks like
only have input. This is based off the pay to public key hash code on.
Yeah. So that's why I say you have to add output here, because otherwise on the network you will fail. But locally,
go for it. Locally, it'll pass.
Yeah, because you see what I just mentioned, right? Because it only check the script; it doesn't check other transaction validation logic. So
that said,
if you add a lot,
this is running on testnet as well, which this is basically pay to public key hash, the same code that is on the examples, and it's running on testnet and it's passing, and it's the same code that is lacking output. So I'm just curious why it fails one chain. Yeah, it both relies on the get claim transaction, and it's both running on testnet. So
okay, yeah, I think this is a little bit more detailed, but we can talk after the in the Slack. I think share me the code. I think it looks like you see why my explanation why it passes locally but fails on testnet, right?
Yeah,
I think it's missing the output, and then pay to public key contract. You can, I think it is somewhere got to be some outputs added, otherwise it would definitely fail, because on the testnet, if you don't have a transaction doesn't have any output, it's definitely going to fail. I think it's somewhere, probably my guess is it's not in this function, probably in some other hidden way. So, and also because it's the pay to public hash, maybe it's because it's almost like a default one. So maybe the underlying library added an output somewhere to get a change or something. So yeah, but I have to check the code. You can share me and definitely help you fix it. Okay.
All right.
But you see, I think the high level, right? This is why.
Yes, I see.
Now
that makes sense to me. That makes sense to me. I was also wondering how, I mean, the recipient is meant to actually receive the satoshis, and that would be definitely through an output specification.
Yes.
Yep, makes sense. Thank you.
Okay, pleasure. Any other questions for today? Okay, if not, we can call it a day, and I think I'll see you all next time, hopefully. Okay, have a good one, everybody. Okay, thanks for coming. Okay, yes, let's talk in Slack. Okay.
Will do.
Okay, thank you. Bye-bye.